Day 527 of doing a LeetCode problem every day until I get a job. All right, y'all, we're back again another day, another LeetCode problem where we're doing daily LeetCode problems. In the day, we have question number 1025, Divisor game. The difficulty level is easy, so you already know we're going to keep the solution as simple and easy to understand as well. But before we get started, y'all, don't forget to like, hype, subscribe, comment, and share. And if you need any new Apple AirPods, go ahead and check out that link in the description so you can get you some. Now let's see what the question says. Alice and Bob take turns playing a game with Alice starting first. Initially, there's a number n on the chalkboard, so on each player's turn, that player makes a move consisting of choose any integer x with 0 being less than x and x being less than n, and n mod x is equal to 0, replacing the number n on the chalkboard with n minus x. Also, if a player cannot make a move, they lose the game. Return true if and only if Alice wins the game, assuming both players play optimally. Alright, y'all, so that sounds simple enough, but let's take a look at these examples just to make sure that we are doing this problem correctly. So, in example 1, we have n equals 2. Our output is true. Explanation says Alice chooses 1 and Bob has no more moves. So let's break this down one step further, right? So let's go ahead. It says there's a number n on the chalkboard. So n equals 2. Let's go ahead and put n on the chalkboard. Boom. N equals 2. Boom. Then it says choosing an integer x with 0 being less than x and x being less than n, and n mod x equals 0. So in this case, it says Alice chooses 1. Boom. So Alice chooses 1. Let's set x equal to 1. Boom. So if x equals 1, so let's go through these requirements, make sure they work. So x is greater than 0 and less than n, right? So it fits that requirement. So it goes 0 is less than 1, and 1 is less than 2. So it fits this first requirement. And then 2 divided by 1 is equal to 2. And since there's no remainders, that means that 2 mod 1 is equal to 0. Since there's no remainders, right? So this mod is just, let me just put this in parentheses. But this mod right here, this just is looking for a remainder. So it's making sure that 2 divided by 1 has 0 remainders, right? So, and that's true. 2 divided by 1 equals 2, meaning there are no remainders left over. So that means it fits this requirement as well. Then it says replacing the number n on the chalkboard with x. So now n is equal to 1. So let's just say n equals 1. Boom. And since n is equal to 1, there are no moves for Bob to make because Bob cannot choose an x that is greater than 0 and less than 1 because they're all whole numbers. And this is the only whole number between 0 and 1. Or excuse me, there are no whole numbers between 0 and 1. And since n is 1, that means Bob cannot make a move. Thus, Alice wins, right? So we return true when Alice wins. So let's take a look at example 2, which is an example where Bob wins. So in example 2, we have n equals 3. Our output is false. Explanation says Alice chooses 1, Bob chooses 1, and Alice has no more moves. So let's go ahead and put n on the chalkboard. So n is equal to 3. Boom. It says Alice chooses 1. So let's say x is equal to 1 for Alice, or we could put a for 1. Alice chooses 1. Boom. Or no, that'd still be x. We put ax. Boom. So Alex chooses 1 for x, right? So once again, it fits the requirements. 0 is less than 1, and 1 is less than 3. Boom. But now, and it fits the other requirement where 3 divided by 1 is equal to 3, which has equal to, let's just say it has a mod equal to 0, right? Boom, because there's 0 remainders. Boom. So then, well, let's clean this up. Let's not be lazy, y'all. Let's not be lazy. Boom. So then, boom, that's what it comes out to. Boom. Okay. So it fits the requirements. So now x becomes 1. Boom. No, x becomes 2. Sorry, because x is n minus x. So Alex chooses x is 1, n minus uh 3 minus 1 equals 2. So now x is 2. So Bob can still make a move if x is 2 because now Bob chooses 1 again, right? It says Bob chooses 1 because x is 2. That leaves room for Bob to choose 1, right? So now this fits the requirement as well because once again, 0 mod, sorry y'all, this should be n equals 2. Boom. So 0 mod, excuse me, 0 is less than 1 and 1 is less than 2. Boom. And then once again, 2 mod 1 is equal to 0, like we did before in the first example, because 2 divided by 1 is 2, 0 remainders, so it fits the requirements. Bob chose his x to be 1, fits all the requirements. And now since x is 1, or excuse me, n is 2, Bob chose 1. So 2 minus 1 is equal to 1. Now the new n is set to 1. And when the new n is set to 1, there's no moves for Alice to make because she cannot choose a whole number between 0 and 1. So that means Bob went last and Bob wins the game, so we return false. Boom. So I hope that makes sense to y'all. And now that we understand the question, let's get into the fun part, the actual solution, y'all. Solution not that difficult. And guess what? I got 2 solutions for y'all today. So make sure y'all stick around for both of them. They're both pretty simple and easy to understand. Now, for the first solution, the first thing we're going to do is we're just going to create a mutable copy of n so it can be modified within the loop. So we're just going to declare a variable called n and set that equal to n. Boom. Then we're going to continue the game as long as n is greater than 1. So we're going to say while n is greater than 1, we're going to open up the brackets. Now we need a variable to store the number Bob will use in his turn. So we declare a variable called Bob num, and we'll set that equal to 0 to start. Now we need to iterate backwards from n minus 1 down to 0 to find a divisor of n. And then so we're going to say for num n, open up the parentheses, 0 dot dot less than sign n, and we're going to come outside of that and say where n mod num equals 0. Boom, and open up the brackets. So the where n mod num equals 0 is going to ensure we only consider valid divisors of n. Then we're going to come underneath that. We're going to say n minus equals num. And Alice chooses this divisor num and subtracts it from n. That's what that does. Then we're going to record the number chosen used to simulate Bob's next move. So we'll come underneath this and we'll say Bob num equals num. Then we're going to stop after the first valid divisor, or the largest possible since we're in reverse order, and we're just going to say break. Then we'll come underneath this right here to simulate Bob's move by subtracting the same divisor value again, and this. So we're going to say n minus equals Bob num. Then when n is equal to 1, Alice cannot make a move, so she loses, and the function will return true if Alice wins or false otherwise. So we could just come right here and we could say return n mod equals 1. Boom. That should be all she wrote, y'all. Let's give it a run. Make sure it runs properly. It should be an E right here. Let's run it again. Make sure that works. Okay, so we got an error. Let's see where we went wrong. Oh, sorry y'all, because we need to do this backwards. So this should be dot reversed right here. Boom. Now let's give it a run before we submit it. Sorry, y'all. And then I submitted it too fast anyway. Supposed to run it first. Thanks. Moving too fast. Should put the parentheses after reversed. Now let's run it. This solution should not be this difficult, y'all. My bad. It's accepted. So now let's go ahead and submit it. Make sure it's still accepted after we submit it. And look at that, y'all. 0 milliseconds beats 100% of users. That's what I'm talking about. That's what I like to see. Now, I know I promised y'all 2 solutions, so let's get into the second solution. Second solution is way simpler. And guess what? We got a one-liner, y'all. That's right. It's that simple. And all we have to do is say n mod 2 equals 0. And this is just going to return true or false. And that's the whole code right there. That's all we needed. Let's run it. It works. Let's submit it. Make sure it's still accepted after we submit it. And look at that, y'all. 0 milliseconds beats 100% of users. Not too bad. Not too bad at all, y'all. So with that being said, I hope y'all learned something today. And I hope to see y'all here tomorrow for another day, another LeetCode problem. See y'all then.